Okay, this is going to be just a brief overview of the initial setup of the system. As you can see, all of the master controllers are turned off, and I'm simulating no power to the counter, so the counter's not lit up, pretending like the battery has been disconnected during shipping and during setup. So what happens is you'll set up your battery connections and get everything routed, and then once the battery is connected, the counters turn on. So they now have their 12 volts in to the green terminal block, and then 5 volts being distributed down to all three master controllers. You can see that the master controllers are still turned off. I've got them turned off with the switch on the bottom, okay? There's a switch on the bottom and there's an LED that would tell you if it's on or off, okay? Now, for the initial setup, you get the doors installed and the belts tightened and everything set up so that the doors are moving properly by hand. And then once everything's set up, we'll push the doors manually all the way open, not banging up against the home switch, but just within, a few inches of being fully open. And then what we'll do is we'll turn on the power to the systems. So I'm turning on the power to all three systems, and each master controller starts doing its initial boot up and testing, okay? And I'll do this one more time with a better focus. Okay, so I'm turning on this system, starting up. It says we have 5 volts for the encoder. It's checking various states, and it's giving us all kinds of faults because the power has been lost. So because of the fact that I had simulated disconnecting the battery, which is how the system would ship disconnected, it's saying, hey, we've lost power, we've lost a lot of connectivity to the encoders, we've lost our position. And it's saying, basically it's saying, you need to rehome, you need to start over, okay? So that being the case, let's look at the screen. And the screen is giving us lots of errors. It's saying invalid. It's saying lots of errors here. And so what we want to do is like I said, push your doors mostly open. Don't press the door up against the button, which is called a home switch, but get it within a couple of inches of it, so that way we know the position of all the doors. Instead of having the doors at random positions and maybe there's a collision of a roller guide, let's put them all close to the home switch within a few inches, okay? That would be door number 1, door number 2, and doors number 3 and 4, okay? Doors number 3 and 4 have one motor. Door number 1 has its own motor. Door number 2 has its own motor, okay? So now that we are, now that we have put the doors in their position for the initial boot up or initial homing, we're going to go to the config screen. So on the LCD, there's 2 screens. You have the main screen, which is showing us faults and invalid states and so forth, and it press the screen button and it puts us on our configure screen. And on here is how we do the basic setup. Okay, the first thing I'll talk about is Rehome. So as mentioned, all of the systems are booted up. We have power to all 3 encoders, all 3 counters, okay? And we're getting errors on all the master controllers saying we've got various faults, you must rehome. So what I'm gonna do is, I'm gonna press the rehome button on the LCD, and then it sends a command to all 3 systems via RS-45, and now all systems start to home. Now, I'm showing you the motion so you can understand the principle of the motors are moving the doors to try to find a home switch. Now granted, we already had our doors very close to the home switch, so this process would be very quick. I'm making it take a long time to demonstrate the concept. Okay, so the door is rewinding or reversing, opening up. The door is moving to the switch. It presses the switch, and it comes back off the switch. When it comes back off the switch, the door will park immediately off of the button within an eighth of an inch or 1/16 of an inch typically. Okay, so each door will press its button. Okay, now the doors are in their fully open 0 position. So homed is fully open and is also 0. And I can show you what I mean by 0. I'll show you that later. We'll go back over more detail of the programming later. But now that we are homed, we can go back to the main screen, and you can see that 10 is a code that I put in that lets me know it's open. So 10 is the code, and then the diagnostic is the door is open. So door number 1 is P1, P2 is door 2, P3 is doors 3 and 4, the biparting lag doors. Okay, P1 is a lead door, P2 is a lead door, P3 is the lag doors 3 and 4. This over here is showing me position 0 inches. Okay, so that means it's basically fully open. This is an indicator that says we're in state number 1, and I'll explain that later. There's various states. State 1 means all doors are fully open. State 2 could mean all doors are fully closed. I don't remember the exact states, but there's various states for every condition that the doors can be in. So it says we're in a valid state. If there were some doors that are out of sequence, or one door's further than it should be, or something's not correct, it would give us an invalid state. Now that we have homed, you can run the doors. So if the doors are fully open, we can press a button called close all, and you can see, sorry about the focus there, you can see all the doors just went fully closed. And on our screen, we're in state number 12, which means closed 2. Closed 2 is the fully closed position for all doors. Doors number 1 and 2 have 3 states: fully open, middle, and fully closed. Okay, whereas door number 3 and 4, they're either fully open or in their, technically you could say their fully closed position, but they don't meet together in the middle. They go to the middle position. So not to confuse it, there is a middle and a closed positions for doors number 1 and 2. There is a fully open and sort of a middle position for door number 3, because door number 3 does not go all the way. As you can see, door number 3 in this example, this is just a mock-up, but door number 3 moved 15 inches. Door number 1 and 2 moved about 30 inches, twice as far. Okay, so they're closed. Let's press open. And you can see all 3 doors just opened up. All right, so that's the basic overview of the initial setup. Again, I will simulate one more time losing power to the encoders. So here's my switch. I'm going to pretend like the battery lost power for whatever reason. Let's say the power went out for 3 or 4 days or got disconnected or something. Losing power, you can see the encoder. Sorry about the focus. The encoder counter lights went out on all 3 systems. There's no power to those counters. And when you lose power to the counters, you start getting errors. Must rehome. It starts giving multiple failures. PCB 5 volt fail, must rehome. Okay, so what we would do in a case where we lost, sorry about this focusing on my phone. When we lose power and we get fault states, and you can see that our screen is flashing some invalid states here and giving us lots of errors. We can go back to our config screen. We can manually push our doors back almost open. Okay, we don't really want them pushing the button, but we just want them close to the button, close to fully open. So I'm manually opening up all the doors, almost fully open. So anytime there's a loss of power to the encoders, the system loses its position. So what we have to do is, to avoid collisions of the doors, having the roller guides bang with other guides, because the system doesn't know where the other doors are, we manually open the doors for Rehome. Okay, I press Rehome. And all three systems start homing. Okay, this one finds home, this one finds home, this one finds home. And once they're rehomed, assuming that all the connections are proper and the battery's working and everything is working right, we are back at a valid state. All doors are fully opened. We can test the doors from the master controller. Close all.